the bottom, but you know, normally they would put the powder in here, the charge, then the shot, and you load it, and I'm going to be loading as if it were a Civil War cannon, with the exception I'll be loading the fuel from the backside. Because this is a projectile coming out of here and it's a force fit, I put a little PAM in here, just a little bit, in both of them. Yeah, Snicker. Now essentially, I take a potato, stick it on here, and the end's tapered. I tapered it so it goes in like that, and then just like you would have done in the 1860s, you load the potato to kind of a preset depth. Watch this, and I have a question for you. Coming down right by the softball dugout. Went behind it. What happened to the time in the air of that thing? It increased. Now, was the range less? Yes. But the time went up. Yes. So as I raise angle, clearly with this, you can see. With that little ball, it's hard to see that. With this, boom, it's there if I shoot like that. If I go straight up, it's like up, down, 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 down. So as the angle goes up, my range may decrease, but my time goes up. How many people get that? Perfect. How many people want to see Big Daddy or hear Big Daddy? Yes. Ready? Now you're impressed. Round of applause.
Shoot it straight up.
Straight up?
Straight up. Straight up. Yeah, straight up.
With that one I will. When I launched it, went 100 feet in the air, maybe 75, 100 feet in the air. The difference in my barrel to that is not much. Theoretically, it is not a delta y equals 0 problem. I started here and ended here, so what's my displacement?
Like a meter.
Give me a figurative field. What's my displacement? Negative. If I launch from here and put one on the roof, what's my displacement? Okay, so you know that. Vertical displacement, just where you start and end. I think Gabrielle was actually mentioning that earlier, that, you know, she said, oh, I get it. Your displacement, I can go anywhere I want in space. My displacement's only from where I start to end. I don't care what the object does through the whole thing. So technically, this is not a delta y equals 0 problem, but often when you do simple problems, we could use the range equation to back calculate our velocity. What would I have to measure in the range equation to get the velocity coming at her? And we did it.
The angle.
Yeah, the angle. I got a hypsometer. I can measure the angle I launch at. What else would I have to measure? Yeah. How would you, what?
Time in the air divided by 2.
That'd be easier way. The moment you hear it launch, you hit start. The moment you hear it stop, then divide that number by 2, and you'll be pretty close. Because if I launch from this height, that little bit over the 100 feet, that's not that much air. There's a little air, but think, there's air in that. We'd be able to figure out really close the time to the peak. That, whatever that height is, it's only like maybe 3/100 of a second you'd add coming down. I'm going to forget about that. That's change. It's like if somebody gave you $1,000, they said, I'll give you $1,000 and a half of a penny. Do you worry about that half of a penny? $1,000 for a half penny. So that little bit you can discount. We know that once you get timed at a peak, you'd be able to know the velocity coming at it pretty accurate. That's what we did too. We measured velocity by shooting up. For AP, we go outside, we shoot these things straight up, and we get velocity. So anybody taking AP next year, you already know the secret.